Video 1.3, measure a spread. Now there are four basic measures of spread, or how spread out your data is. The first one is range. To calculate range, you just take the max minus the min. Next one is something called the interquartile range. This measures the middle 50% of your data, and that is quartile 3 minus quartile 1. Next we have variance. If I'm looking at the variance of a sample, I will use the symbol S squared. If I'm looking at the variance of a population, we'll use sigma squared. We'll start with using the sample squared definition, and then we'll get to some population data later on in the year. And the last measure of spread that we need to know about is called standard deviation. It's abbreviated as S or sigma. S stands for the sample. Sigma, of course, is associated if your data is from the entire population. So we're going to be dealing with S and S squared in this video. So what is the measure of spread? Measure of spread describes how similar or varied the set of observation values are from a particular value. It's used to describe the variability in a sample or population. We'll be dealing with a sample in this video. So look at these two distributions. We have distribution A and distribution B. They're both symmetric distributions, but when we look at it, distribution B is more condensed, whereas distribution A has a greater spread. So if we looked at the range of distribution A, we take the max value minus the min value. Our range for distribution A would be 10. Let's compare this to distributions B range. Again, range is found by simply taking the max value minus the min, so this would be 9 minus 4. So distribution B has a range of 5. So notice the distribution A is double the distribution of B. So that tells us that distribution A has more spread out data. Like distribution A data is twice as spread out as distribution B's data. So range is maximum value minus minimum value. But in a quartile range is the range of the middle 50% of your data. Interquartile range, abbreviated IQR, is equal to, you find this by finding quartile 3 minus quartile 1. So the formula for interquartile range is Q3 minus Q1. So how do I find my interquartile range? Well, the first thing you have to do is you have to organize your data into increasing order. The reason why we have to organize into increasing order is so that we can find the median. And that's step 2. What is the median of your data? We learned how to find median in the last video, which is the middle of, divides your data into 2 equal halves. It's the middle value. Then you look at the lower half of your data and you find its median. And you look at the upper half of this data and you find its median. The median for the lower half of your data is called quartile 1, and the median for the upper half of your data is called quartile 3. And finally, you find your IQR, your interquartile range, by taking Q3 minusing Q1. Okay, so let's look at an example. We're going to try to find the range and interquartile range of the data set below. So the very first step in order to find either range or interquartile range is to organize your data in increasing order. So let's rewrite this data in increasing order. Now that I have my data in order, I can easily find the range. Recall that range is the max value minus the minimum value. So our range, to compute it, will take 292 minus 120. So the range of the data in this example is 172. Next, we're going to look at trying to find the interquartile range. Remember, interquartile range is Q3 minus Q1. So in order to start, I must first find the median of my data set. I have 12 data values, so our middle number is going to be at the 13 divided by 2, or 6.5. So it's going to be halfway between the 6th and the 7th data entry value. So that's 155 and 158. So I'm going to take 155 plus 158 divided by 2. And I find the median is 156.5. Then I'm going to divide the data, not including the median value, but all other values less than it, and find a new median, the median of the lower half of the data, which is halfway between 128 and 140. This is what Q1 is, quartile 1, the median of the lower half of the data. So I find that Q1 is 134. Next, I'm going to find the median of the upper half of the data, all data points larger than the median. So to find Q3, I find the average between 161 and 163, which is 162. Then, to find my interquartile range, the range in which the middle 50% of my data, I take Q3, 162, minus Q1, 134. So my IQR, or interquartile range, is only 28. So although my original data spans 172 values, my interquartile range, the middle 50% of my data, only spreads out in between 28 values. Next, we're going to discuss how to find sample variance and how to find standard deviation. So we're going to start with sample variance. To find the sample variance, you take the summation of your data points minus the mean, quantity squared, divided by the number of data points you have minus 1. So the formula for S squared is summation of xi minus x bar divided by 2 over n minus 1. So how would we do this? Step 1, we find the mean, x bar. Step 2, we're going to calculate xi minus x bar quantity squared. Step 3, we're going to find the summation of those calculated values. And then finally, step 4, we're going to divide by the number of data points minus 1, or n minus 1. So we're going to look at the same example we did earlier, but this time we're going to look at finding the variance and standard deviation of this data. So first we're going to calculate our mean. Remember, mean is the summation of our data points divided by n. Now, to help you save some little room, you may do a little notation where you write a few data points plus ... plus the last data entry and then divide by n. Using your calculator to figure out what all these data entries added together is and divide them by 12, we find that our mean is 159.333. Calculate variance and standard deviation by hand. Usually need a table. In the X line, I'm going to put all my raw data, so each data entry point. For the second column, all we have to do is take each individual data value and subtract the mean, and that'll give us our second column. So for our first row here, I take 120 minus my mean of 1,912 divided by 11, choosing to write it as a fraction so I don't have to write all the decimal places. I get negative 39.33. All that means is this data point is to the left of the mean by 39.33 units. I'm going to repeat this process for all the other data points in my sample. Since I don't care if it's to the left of the mean or to the right of the mean, I just want to know the distance it is from the mean, I'm going to get rid of my negatives and, by squaring each of these values. So that's going to be my last row in this table, my last column in this table. So I'm going to take my answer, negative 39.33333, and square it to get 1,597.110849. Then I'll repeat this process, squaring each of my values from the second column to complete the third column. One thing I'd like you to notice from this table is data entries that are far from the mean, say the 292, which is an outlier that's far from the mean, has a great drastic impact on our total, which will affect our variance and our standard deviation. because the 292, when I subtract mean and square it, it has over 17,000 contributing to our variance. Whereas data points close to our mean, such as the 161, only contributes 2.777 to our variance and our standard deviation. So with that knowledge there, you can conclude that variance and standard deviation are non-resistant measures, which means they are easily impacted by outliers or unusual values. Now recall our variance formula is a summation of x minus x bar squared, which is our last number in purple on this table, divided by n minus 1, or divided by 11. Using my calculator, I figure out my variance in this problem is 1,982.96. Standard deviation is equal to the square root of variance. Now to find the standard deviation, I'm going to use the formula. Standard deviation is the square root of variance, or standard deviation is equal to the square root of the summations of x minus the mean quantity squared divided by n minus 1. Now this is a formula when we're looking for S, standard deviation of a given a sample. So notice it is the square of the standard deviation is equal to variance. So the square root of variance is my standard deviation. So to find my standard deviation in this problem, I take the square root of 1,982.969 and I use my calculator. I get my standard deviation is 44.53. See, making a table of values for every problem we want to find variance and standard deviation can be quite tedious. Therefore, we're going to use our graphing calculator to help us do this problem. Let's look and see how calculators can help us find standard deviation. So let's start by going to our Stat button, and we're going to edit, and in this first line we're going to input our data in list 1. So we're editing in list 1 our raw data. So my first data point is 120, then 140. I'm going to go ahead and add in all 12 data entries. I like to go through and double check, go back and recheck I have all my data entries inputted correctly. If I make a mistake, I'm going to get an answer that's incorrect. Once you do that, you're going to go to Stat button, cursor over to Calculate, and then one variable statistics. In the list, you need to put the list in which your data was entered. We put it in L1, then push Enter, Enter. You can see in the yellow highlight, we have found our standard deviation of problem, 44.53, as we found from the table. If you do decide to use your calculator, you do still have to show work. So this is the problem of how much work you'll need to show if you're using your calculator. So first you will have to show finding the mean. So I find the mean by adding up all my values. Now you don't have to write down all the data points, just write down the first two plus dot 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 plus 155. And then divide by the number of data points, or 12, and then just write the answer you get from your calculator. So my mean is 159.333. Then I would find my standard deviation next. So I do my standard deviation, and I'll use my calculator to figure out my standard deviation. But to set up and to show my work on my paper, I would start with the formula. Standard deviation is equal to the square root of, then write down my first data entry, minus my mean, 159.333, quantity squared, plus, then repeat that for my second data point, quantity squared, plus dot 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 means I continue this pattern for all data points until I get to my last one, and then I need to write my last one down. 155 minus my mean, quantity squared. Divide by n minus 1. So I'd say divide by, in this case, 12 minus 1. Then I go to my calculator, put it in like I just showed you how to do it in your calculator, get the highlighted line, and then copy the highlighted line down and round to how many decimal problems the problem says. So here my standard deviation is 44.53. Then all I need to show for variance is you need to recall that how variance and standard deviation are related to each other. Variance is equal to the standard deviation squared. So I take my standard deviation, square it, and that gives me my variance for this problem.